Hi class, we're covering section 2.3, which covers lines, and this stuff is covered in algebra class. Now you might have taken that in high school, and it would be called Algebra 1 or something similar, or you took it on our campus, it would be called Math 45, beginning algebra. So these topics should be very easily reviewed. I just want to point out one thing. A lot of people, whenever I ask about slope, they always give me this slope-intercept form of a line. And notice that the word slope is actually in every single one of these. Slope is used widely. We have to make sure that we don't mix up our formulas. So I'm going to be filling this in very quickly. For the slope of a line, we use the letter M to signify slope. If you have 2 points, point 1 and point 2, you would subtract the y2 minus y1, divide by x2 minus x1. A lot of times we refer to this as rise over run. A direct result of multiplying both sides by the denominator in the slope equation gives us a formula for the point slope form of the equation of a line. And you can see that you need to know at least one point and the slope, and then you plug it in this way into an equation. The y minus and the x minus don't change ever. You just fill in the m and the x1 and y1. The slope-intercept form of the equation of a line is the most famous, I think, and it's just y equals mx plus b, filling in m for slope and b for the y-intercept. The equation of a vertical line is just x equals a, where a is the x-intercept value. The slope, because it's vertical, the slope is undefined. And for a horizontal line, the y-intercept is b, so you get the equation y equals b, and the slope is 0. The general form of any equation is always in alphabetical order for the variables, and if the variables had powers on it, we would go in descending order of the power. Because this is linear, the powers are 1, but we still put in alphabetical order, and we just put the coefficients as capital A, B, and C. Typically, we like to think of them as integers, aka whole numbers that are positive or negative. The criteria for parallel lines is algebraically that they have the same slope. Now we can define it in other ways, like in geometry we say parallel lines never intersect. But for algebra, we want to use the slope to define them. And notice that the slope in each of the equations that I've given to you, the slopes are the same because they're equal. We know that perpendicular lines intersect at a right angle. That's the geometric definition. But for algebra, we want to prove it using the slope, and we have the fact that the slopes are negative reciprocals of each other. Another word that they sometimes use for this is that the product of the slopes is -1. But if you take a look at this, -4, and we have positive 1/4. If you multiply them, they would get -1, but also you can tell that they're reciprocals of each other, and one is negative, one is positive. Applying what we just wrote, the definitions, we can do number 1. It says to find the slope of the line containing the given points. I've written down the points as P1 and P2. To find the slope, we remember the formula. It's y2 minus y1 over x2 minus x1. In this case, that's 2 minus 1 over 2 minus -1. And so that gives me 1 over 3. And so my slope means that I go up 1 and over 3. We didn't need a graph number 1. Number 2, we're going to label our points as point 1 and point 2, and it doesn't matter the order in which you do it. It just matters that you pick one and stick with it. We're going to say y2 minus y1 over x2 minus x1, and so that gives me 0 over -9, which is just 0. A slope of 0 means that I have a horizontal line, and if I know my y-intercept, well, all my y's are going to be the same, is going to be 2. And so we're going to say the equation of the line is y is equal to 2. A quick sketch of the line, we know that it's horizontal, we know its y-intercept is 2. And so you would just be drawing a horizontal line as best as you can that goes through the point 2. And we're going to label the line. Question number 3 asks us to locate 3 more points on the line if we are given the slope and the point. So I know that you can do it just by graphing it and identifying the points, but I'm going to do it algebraically. I want to just point out that when we know the slope and it's given as a whole number, you can always write whole numbers as fractions. And so I'm writing as 2 over 1, and 2 is my rise, and 1 is my run, meaning that's how much it goes up and how much it goes over. And so we have that information that's going to help us. The 2 is my change, also known as my change in y values, and my 1 is known as a change in x values. So if I have a point -2, 3, I'm going to add 1 to the x values, and I'm going to add 2 to the y values, and the next point I'm going to have is -1, 5. We can do this again. Go up 2 over 1, and I'm going to get 0, 7. Or alternatively, I could start at this point and say, you know what, I don't want to go up, I want to go backwards. So if I had the fraction 2 over 1, that's the same as -2 over -1, right? So I'm going to subtract 1 from my x values and subtract 2 from my y values. I'm going to get -3, 1. So my 3 other points are -1, 5, 0, 7, and -3, 1. Number 4 asks us to graph the line that contains the point 1, 3 and has a slope of -2/5. It's very important that when you're graphing that you label your lines so we know exactly where your scale is. You're going to start at this point. You always have a starting point, and then you figure out what direction you're going. I'm going to write the slope again. My slope could either be -2 over 5, or it could be thought of as 2, -5. Let's go over the first interpretation. The -2, 5 means that you're going to go down 2 and over 5. So we're going to go down 2 and go 1, 2, 3, 4, 5. Alright. This other interpretation we have here, it means that you're going to go up 2, and then you go -5, meaning left. You're going to go up 2, and go 1, 2, 3, 4, 5. Alright. You want to draw your line, not just to connect the dots, but you want it to go from edge to edge of the frame that you have here, and arrows on both sides to make sure it continues on and on. And the question doesn't ask for it, but let's go ahead and practice writing this equation of a line. We know that we have a point and we have a slope, so we're going to use the point slope form. And you're going to say y minus y1 is equal to mx minus x1. Let's fill in those pieces. So I have y minus 3 is equal to -2/5 x minus 1. And there's the equation of the line. Question number 5 asks us to find the equation for the line with the given properties. And this graph is actually something that we already found the slope for. So I'm recalling the slope from our previous question. And I want to say that I'm going to use the slope and one of the points. So the point is -1, 1. We're going to take this information, put it in point slope form. Now I know that's not what's asked, but that's what we have the information for. So I'm going to go y minus y1 is equal to m times x minus x1. And just simplifying what we have here, this is what I get in point slope form. Now, like I said, that's not what was asked, so let's first change it to slope-intercept form. We're just going to do that by multiplying this out and then adding 1 to both sides. Now they also want this in general form. That's going to be moving my x's to the same side. So I'm going to get negative 1/3 x plus y is equal to 4/3. And I'm going to multiply everything by 3 just to get rid of my denominators. And if you want, you can also multiply by negative 1 just so our equation starts with a positive number. You don't have to, but you can. And so that was the general form. Now, like I said, we had to start off finding our equations by doing it in point slope form. Even though that wasn't asked of us, that is the only information I had. I had the slope and the point, and I have to put it in that format first and then rewrite my equations to be in the formats that were requested. Okay, we're going to find the equation again, and once again we have the point and the slope, so we're going to use the point slope formula, and it's going to be y minus y1 is equal to the slope and x minus x1. But that's not what's asked. We want to put it in slope-intercept form, so I'm going to simplify this. I'm going to subtract 3 from both sides. So my y-intercept is 11. Let's go ahead and put this in general form, moving the 2x to the other side with the y. We have negative 2x plus y is equal to 11, or multiplying by negative 1. Sort of just makes everything look nicer. Here's my general form. Now it's not, you don't have to multiply by negative 1. I just like my leading coefficient to be positive, and there's less negatives overall in the second format, so I'm choosing that to be the format I'm turning in. For number 7, we actually are given the slope and the intercept, so we can go straight to slope-intercept form. And so we're going to get y is equal to m x plus b, and b is negative, so I'm just going to put minus 2. And there we go. We already have it in the one format that we want. And then to move things over to the other side, I'm going to add 2x to both sides. And here's my general form. So this one was much easier because of the given information. Now, you always have to start off with whatever information you have, no matter what the request is. Number 8 tells us that the slope is undefined, and we know that that means that it's a vertical line. So let's just write that down. It's a vertical line. Vertical lines have the formula x equals a, and whatever value is the x, that would be it. Now this one you can't write in slope-intercept form because there is no intercept, and so that's all you can do. You can write it this way. This is the general form because there's no y, and we're done. Now you could take this information and plug it into point slope form, but you could also recognize the fact that if the slope is 0, then we have a horizontal line. And if I have a horizontal line, I know that its formula is just y equals. And so I'm just going to say y equals, and the y value is negative 1. And there you go. But let's say we don't recognize that, and you want to go the long way. Let's do point slope form. It would be y minus y1 is equal to m times x minus x1. But then you would get y plus 1 is equal to 0, we get y is equal to -1. So no matter which method that you use to get there, you should get the same answer. Continuing on, we want to find a line parallel to 2x minus y equals -2 and want it to contain the origin. Now we know because it says parallel, we want it to have the same slope, but it's not written in any way. It's written in the general form, and I can't find the slope with that. So I'm going to subtract 2x from both sides. And I'm going to divide everything by -1. And so now I know that my slope is +2. And because it says parallel, we want it to be the same. So then my equation is now going to be y minus 0 equal to 2x minus 0. In other words, y is equal to 2x. This is my slope-intercept form of the line. If I want to make it general form, I'm going to move that over to the same side. Say -2x plus y is equal to 0, or 2x minus y is equal to 0, which is my preferred way. Number 11 asks us to find the line that's perpendicular to another line, so we're going to find the slope. And also we want to contain a point, so we're going to use the point-slope form of a line to find this equation. Now it's perpendicular to that line. The slope in this given line is 2, but because it's perpendicular, I want the slope to be the negative reciprocal. I'm going to say -1/2. And then the point I want it to contain is 1, -2. And take this and put it in the point-slope format. That's going to be y minus y1 is equal to -1/2 x minus x1. And simplifying this, we get -1/2 x plus 1. And subtract 2 to both sides, and we're going to get -1/2 x minus 1. And that's my slope-intercept form. And then adding 1/2 to both sides, I'm going to get 1/2 x plus y is equal to -1. I just want to multiply by 2 to get rid of my fractions. That would give me x plus 2y is equal to -2. And this one's the general form. Now for the last 3 questions of this section, we're asked to find the slopes and the intercepts. So what I'm going to do is take this line that's written in general form and rewrite it in slope-intercept form to find that information. Now to do that, I want to isolate the y. So I'm going to subtract 1/2 x and I'm going to multiply by 3. And this is slope-intercept form. Now, that's not really what the question was asking, but now I can give the answer to the slope. The slope is -3/2. And we also want to find the intercepts. Now, they don't say just find the y-intercept. And that's a little misleading because we have it in slope-intercept form. It'd be very easy just to say the y-intercept is 3. But we also are asked to find the x-intercept. When they say intercepts, you want to find all of them. And to get my x-intercept, I want to plug in y equals 0. So if I do that, then I'm going to get 0 is equal to -3/2 x plus 3. Subtracting 3 from both sides gives me -3/2 x. We're going to get rid of that coefficient by multiplying by its reciprocal. And when I do that, I'm going to end up with a +2. And so this one is my x-intercept. And we want to find the slope and the intercepts. But we have this line, and we have to recall that it's horizontal. So since it's horizontal, its slope is going to be 0. And its y-intercept is -1. But it doesn't have an x-intercept. Let's graph it real quick. It's going to be a horizontal line going through -1. But since it's horizontal, it's parallel to the x-axis, I won't have any x-intercepts. Okay, so we have this line, and it's not written in any format that we recognize right off the bat. But if I isolate the x, I'm going to get x is equal to 2. And this should clue us in that we have a vertical line. When we have a vertical line, then my slope is undefined. But I do have an x-intercept of 2, and I don't have any y-intercepts. Because it's a vertical line, it's not going to cross the y-axis because it's parallel to it. This whole section should be reviewed. We did 14 questions, but this should have been learned a long time ago. If you're stumbling on any of these questions, make sure you practice a lot and make sure you get really good at this, so that this isn't a stumbling block when you're in college algebra. Thank you, and have a good day.